I'm Anil Kumar, sharing with you a test question on velocity applications. A yacht is sailing at a constant speed of 5 square root 10 kilometers per hour in the direction minus I minus 3j. Initially, it is at position minus 6, 10. A beacon is at 0, 0 at the corner of a tiny atoll. Write position vector for the yacht. When is the yacht closest to the beacon? Find whether there is a possibility that the yacht could hit the reef around the atoll, given that the atoll has a radius of 8 kilometers. You can always pause the video, answer the question, and then look into my suggestions. We have to write the position vector. Position vector is actually a function of x and y. So we can say x of t, y of t is equal to initial position, which is given to us, but in general I'll write this as x0, y0 plus t times the velocity. Velocity in x direction and in y direction, right? Now in the present question, we are given speed and the direction. Now speed is 5 square root 10 kilometers per hour. Direction is minus 1i or minus I minus 3j. We can find velocity as, velocity could be written as the magnitude of velocity, which is speed, and then a unit vector in the given direction. So first step should be to find the unit vector in the given direction. That is, we need to find what unit vector is for this given direction. So direction given to us is minus 1, minus 3. To find unit vector, we'll have to divide this by its magnitude, which will be minus 1 square plus minus 3 square, correct? Now that gives you so that gives you minus 1 minus 3. 9 plus 1 is 10, so square root of 10. So this becomes the unit vector. So I hope you understand the concept. We have the direction m, which is given to us as minus 1 minus 3. To find unit vector in this direction, we have to divide m by its magnitude. We have to divide m by its magnitude, correct? So that is the magnitude of the direction vector, right? Now, once you have this, you can actually write down the position vector. So let's write down the position vector now. So position vector, let's write xy is equal to, initial position is minus 6, 10 plus t, and for velocity we are given speed of 5 square root 10, and the unit vector here is minus 1 minus 3 divided by square root 10. So this square root and square root cancels, and therefore you can write a simplified version, which, let me write here itself, could be written as position vector I'm writing, not the, we'll do part B in the next page. So it should be minus 6, 10 plus 5, we'll multiply these numbers by 5, so we say t, minus 5 minus 15, correct? So that is how we can actually write the position vector in the given situation. Okay. You would also write this in parametric form. So let's write down in parametric form also. We can say x is equal to minus 6 minus 5t, and y is equals to 10 minus 15t. Correct? So that is the result for part A. Now for part B, when is the yacht closest to the beacon? and beacon is at 0, 0. So beacon position is 0, 0. We'll do this in the next page and also see the distance. Once we know the distance, we'll know whether it is within 8-kilometer range or not, correct? So let's move on to the next page and solve part B. So let me copy the position vector, which I have already done, which is the position vector is given as xy equals to minus 6, 10 plus t minus 5 minus 15, right? Beacon is at position 0, 0. So when we want to find closest position with the beacon, let me show it with the help of a diagram how we can do it. So what we are trying to say here is that let's make let's say the initial position is minus 6 and 10 somewhere there, and it moves minus 5, minus 15, kind of like this, less in this direction. So that's the path. Now we want to find the closest distance from the origin. So that is O. Let this point be any point R on this line, which is the path of the yacht, correct? Now, in general, what is OR equals to? So general point R could be written as, a point R could be written in this form, right? So the x coordinates for R will be minus 6 minus 5t, and the y coordinates will be 10 minus 15, correct? Now O is at the origin, so that becomes the position vector OR also. For OR to be perpendicular to this path, let's call this as P. What is the direction of this path? Let's say the direction of path is this velocity vector. So let me call this as velocity vector, which is minus 5 minus 15. So these two dot products should be 0. Okay? So we should have OR dot velocity should be equal to 0. Now OR dot velocity is what? So let's do dot product of these two. We have minus 6 minus 5t times minus 5 plus this is 15t. 10 minus 15t times minus 15, correct? So that gives us 0 equals to, let's multiply, minus minus becomes plus 30, plus 25t. 10 times minus 15 is minus 150, and 15 is 225. That should be equal to 0. Combining these terms, we get 120 with a negative sign, and this is 250. And therefore, t is equal to 120 divided by 250, correct? So we get a value of t which is 120 divided by 250. Since we know this value of t, we could actually write decimal equivalent. Let's do it. 120 divided by 250. In decimal, it is 0.48. So once we know this, we can actually find the coordinates for r, correct? So now let's find what are the coordinates for r. So we can get from here, r will be equal to minus 6 minus 5 times 0.48, and 10 minus 15 times 0.48, correct? And that is, let's calculate. Both are negative, so we'll just do 6 plus 5 times 0.48, which is in decimals 8.4 negative. And here we have 10 minus 15 times 0.48, that is in decimals 2.8. Okay. So that becomes the coordinates for R. Now, if that is the coordinates for R, then how much is the minimum distance? That is closest to beacon, right? So that is the beacon. So distance OR, that is absolute value of OR, is equal to square root of minus 8.4 square plus 2.8 square, which is, let's figure it out. So it is square root of 8.4 square plus 2.8 square, and that is equal to, in decimals, 8.85. 8.85. The units are kilometers, right? So this distance is 8.85. So that is the closest distance. Well, in the question, we were also given that the radius for the reef is 8. So that is kind of 8 like this. So that is 8. So as you can clearly see, that the yacht will be on safe distance, correct? So it is not going to be close, it is not going to touch the reef, right? So since 8.85 is greater than 8, will not touch reef. So that is part C, and the distance is 8.8 kilometers. So we have 8.85 kilometers. So that is how you could actually solve such a question. So there are a lot of steps involved in it. Try to go slow, try to understand each and every step. Feel free to write your comments and share your views. If you like and subscribe, that'd be great. Thanks and all the best.